Time for the lesson on ellipses. Remember, an ellipse is a conic section. If you take a cone and cut it by a plane, but you cut it at an angle, you end up with an ellipse. It looks like this. Okay. And an ellipse is the set of all points x, y in a plane that the sum of whose distances from the 2 points, the foci, is constant. All right, so there's a center here. And then there's 2 points called the foci. They're on the long axis. The major axis is always the longest one. So this one's a horizontal major axis because it's longer in the horizontal direction than the other one. What this definition tells me is if I pick a point here and measure this distance and this one and add them up, it's going to be the same as if I pick this point and pick that distance and add them up. Or this one, this distance plus that distance. It's always the same answer when you get done. Okay? All right, so the parts of my ellipse, well, I might as well start over. So here's my ellipse. It has a center at HK. It has a minor axis is the short one, so that's minor. The major is the long one. Okay, so you can have an ellipse going this way also. Still has a center, and now this one's the minor, and that one's the major. How do you tell the difference? Whichever's bigger. If the A is bigger, it's under the X, it's longer in the X direction. If the B is bigger, it's under the Y, and it's longer in the Y direction. That's how you know. The ellipses are always on the major axis, okay? I mean the foci. Always on major axis inside ellipse. Okay, if you do your calculation and end up with a foci out there, you did something wrong. They got to be inside, all right? So I got to put my major axis back. All right, these are the foci. I mean, they talk about the vertices, okay? They talk about vertices. Those are these points. Well, the distance from here to here is A, and that's A squared underneath. Okay, so this is A. The distance from here to here is B. The distance from here to here is B, is what's underneath the Y. So you add that B value to the Y, and you add the A value to the X in order to get these vertices. All right, the foci, you take the difference between these two. You use absolute value, or always subtract the little from the big and take the square root. It'll give you the distance away from center, okay? So write that down. C is, C is distance from center on major axis. Major axis. All right, so let's do some of these. And identify important points. So let's find the center. The center's at 4, -1. So I come over here and go 1, 2, 3, 4, -1. Now, my vertices in the X direction is the square root of 9 is 3. So it's 1, 2, 3, and 1, 2, 3. So vertices, I was at 4, and I'm going to add 3, so I get 7. I'm at 4, and I subtract 1, and I'm at 1. In the Y direction, it's 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so my 4 didn't change. And I was at -1 and added 5, so I got to 4. I'm at -1 and subtracted 5 and got to -6. So now I have my vertices. And if you draw on here, it should make an ellipse for you. See, isn't that fun? It's an oval, all right? Now we need to know the major axis. You add up. The major one's the long one, so it's 5 in both directions, so it's 10. The minor axis is the short one, which was 3 in both directions, so that's 6. And then we have to find the foci. Okay, so you take the square root of 25 minus 9, which is the square root of 16, which equals 4. Now remember, they're on the long axis. So I'm going to start at the center and go up 4, and I'm going to start at the center and go down 4. The x didn't change, the y did. I went from negative 1 and added 4. And I went from negative 1 and down 4. And that's the major stuff you need to know about an ellipse. The center, the vertices, how long the major minor axes are, and where are the foci. So here's another one, same thing. Center, negative 2, negative 2. In the x direction, I'm going 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The y direction, you go up 2 and down 2. See if I can draw another one without it screwing up. I did it. I'm so proud. All right, vertices. Well, I'm still at, the y is still negative 2. Right? What did I do? I started at negative 2 and I added 6, so I get to 4. I'm at negative 2 and subtract 6, you get to negative 8. And then I went this way, and my negative 2 didn't change, and I added 2 and got to 0, and I subtracted 2 and got negative 4. Vertices, C, the foci I mean, C is equal to 36 minus 4, which is the square root of 32. Well, that's not a pretty number, but we leave it that way because it's exact. So how do I find the foci? Well, the foci, remember, are on here. The square root of 32. Well, 4 squared is 16, 5 squared is 25, 6 squared is 36. So it's somewhere between 5 and 6. So it's out here. All right? But it's the x value that changed. My y didn't. My y is still negative 2. My x went from negative 2 plus or minus the square root of 32. Okay, so I have the foci, the vertices. Oh, and I need to know how long the major axis is and the minor axis. The major axis is 12, the minor is 4. Done. All right, write an equation of the ellipse. Endpoints are at, this one I screwed up because I didn't read it correctly. All right, at 10, 2, and so over here at 10, 2, and negative 8, 2. Those are the endpoints. The foci are at 6, 2, and negative 4, 2. So the center has to be in between those, halfway in between. Well, that's 8, so it's right here at negative 1. And you're 5 that way and 5 that way. Okay, so we know in the x direction, the length is, that's 9, so that's over 81. My center is at negative 1, 2. Oops. So it's x minus a negative 1. Is that right? Oh, it's at positive 1. Sorry. So that's x minus 1. The y direction I don't know yet, but we know this is y minus 2. All right, so I have to figure out how long this is. Well, I know that c is equal to 5. So c squared is equal to 25. And that's equal to, this is the big one, 81 minus b squared. So 25 minus 81 equals negative b squared. Or so you get 81 minus 25, and you get 56. So b squared equals 56. And I don't really care. So that's 56. And it equals 1. They're always equal to 1. That's a key point. So let's scroll back up here and highlight that. Always equals 1. Always equals 1. And that's all we had to do. Write the equation. All right, this one we have to graph it and do important stuff, so it's a complete the square again. Remember, you separate your x's, so you have 4x squared plus 40x plus a box plus 36y, 36y squared minus 288y plus a box equals negative 532 plus a box plus a box. Well, here you factor out a 4, and you get x squared plus 10x. Half of 10 is 5. 5 squared is 25. But 4 times 25 is what I add over here, so my box isn't big enough. So I'm going to add 100. Here I'm going to factor out 36. What's 288 divided by 36? 8 minus 8y. Half of 8 is 4. 4 squared is 16. In my box, which again is not big enough, I have to do 36 times 16. 16 times 36 is 576. Okay, so now you have 4x squared, x minus x plus 5 squared plus 36 times y minus 4 squared equals what? Negative 532 plus 100 plus 576 is 144. Now remember, it has to equal 1. So you go through and you divide by 144. Divide by 144. 144 divided by 4 is, 36. So I have x plus 5 squared over 36 plus y minus 4 squared over 4 equals 1. So my center is at negative 5, 4. Negative 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 4. And I'm going to go 6 in the x direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 2 in the y. And there's my ellipse. Okay. In the foci, it's the square root of 36 minus 4 is the square root of 32. It's on the long one, so it's negative 5 plus or minus the square root of 32 and 4. Those are the foci. And the endpoints I'm not going to really worry about. You can add and subtract those. And that's all there is to an ellipse.